Right, number 14. Find the turning point of the function y equals x squared minus 4x plus 5. Okay, and then the second part, state the nature of the turning point. Okay, we'll get to that in a minute. We'll get the turning point first. So we know at the turning points, girls, we know that dy dx equals 0. Right, okay. So let's get dy dx. So dy dx is equal to, bring the power down in front, which is 2x. Differentiate minus 4x, you get minus 4, right? And you let that equal to 0. So there's no x squared terms, just an x term. So that's x's on one side, numbers on the other. So leave the 2x, bring over the minus 4, becomes a plus 4. Right, divide each side by 2, and you get x is equal to 2. So they asked me for the turning point, so I have the x value now. So in order to get the y value, I'm right back up at this chart. Y equals x squared minus 4x plus 5. So that means y is equal to 2 to be squared minus 4 times 2 plus 5. Into the calculator with that, and we'll get 1, I think. Yeah. Okay, so your turning point is 2, 1. Now, they said use d2y dx2 to determine the nature of the turning point. Right, but if, sorry, did I, yeah.
Yeah, how do you always know to find x? Like, when I did that, I just went straight into the minus b and not...
because you're solving 2x minus 4, equals 0. You don't use the minus b formula if there's no x squared term. You only use the minus b formula if there's an x squared term.
Okay.
And you're solving 2x minus 4. So there's just x on its own. There's no x squared. So that's just x's on one side, numbers on the other. Okay, for the minus b formula, you need an x squared term. Is that okay?
Yeah.
Right, okay. So, girls, before we do the next bit, right, tell me, shape of this, right, what will shape of that? It'd be a smiley face, wouldn't it? Because there's an x squared term, right, and it's positive, so that means we're smiling. So what kind of a turning point is it? Minimum. You know that in advance, okay? But they want you to use the mathematical way to find whether it's a max or a minimum, right? Okay, so to do that, we take dy dx. So we had dy dx equals 2x minus 4. We differentiate again, and we call it d2y dx2. Okay, and it's written in the question if you can't remember what it's called. d2y dx2 is, differentiate here, what do you get? 2. Then we'd fill in x, but there's no x to fill in, right? Okay, d2y dx2, is that a positive or a negative number? Positive, it's plus 2, isn't it? So it's a positive number. So when d2y dx2 is positive, what can I say? It's always a minimum, right? So if it's positive, it's a minimum. If it's negative, it's a maximum. So you don't have to fill in anything here. You just differentiate, and you'll always end up with a positive number because there is no x to fill in. Do you know what I mean? Normally we might get 2x, and then you'd put in 2 for x. Right, okay, but this time there's no x, so it's always positive, which means it's always a minimum, which makes sense because there's only a minimum turning point here. Isn't that all? Right, okay, are we okay? 15, am I doing it? Might as well. Right, okay, so number 15. The function y equals x cubed plus 3x squared is graphed, minus 9x is graphed, right? Okay, so we know it's this. So it's got 2 turning points here and here.
Miss, how do you know it's got 2 again?
It's drawn for you, right? But if they didn't draw it for you, you'd look at the x cubed term, and look, a cubic one is always like that, or it's like that, okay? right? So you look at the x cubed term, if it's positive, positive means everything is good and you finish on a high. So it means it's this one, okay? Is that alright?
Yeah.
So positive x cubed means it finishes on a high. If it was a negative x cubed, you're down in the dumps, so you finish on a low. Right? Is that okay? Right, but they've drawn it for you anyway. Right? So there's two turning points, right? And obviously this one's going to be the max, and this one's going to be the min. Right? Because the max is the one that's up high, and the min is the one that's down low. Okay? So when we solve this, we have to get two answers. We have to get 2 points. Okay? So show that there is a turning point at 1 minus 5. Let's pretend they haven't told us the answer. Let's just get the answers. Right? And we'll say they're asking me for the turning points. So at the turning points, TP girls, the rule is dy dx equals 0. Right? I now have marks. I've now passed that question because I've written down the rule. Okay? Right? So they throw marks at you in maths. Okay? So never should you be getting 0 in the sum. You should always be getting at least 10 marks. Okay? So dy dx, differentiate dy dx, and you get what you get. What I get? 3x squared plus 6x minus 9. Now, this time you would use the minus b formula. Why would you use the minus b formula? What's in there that tells you to use the minus b formula? An x squared term, right? So you could use the minus b formula. A would be 3, b would be 6, and c would be minus 9. Okay? Off you go. Yeah.
I did minus b formula, and I also, before I started it, I
Divided across by 3?
Yeah.
Yeah, brilliant. Right, you had smaller numbers, makes your multiplying out easier. Okay? So if you're using the minus b formula, go ahead right there and use the minus b formula. Me, I'm going to notice everything divides by 3. So those, and I get x squared. 6 divided by 3 is 2x. 9 divided by 3 is 3. Okay? So I'm going to use my two sets of brackets to, by the way, if you want to divide by 3 and then use the minus b formula, right, that's perfect too. Right? Okay? So two sets of brackets for me. X and x. Factors of 3 are 3 and 1. A minus tells me I'm putting different signs. Here I'm going to put a plus 3 and a minus 1. Check your answer. On the inside I have plus 3x. On the outside I'll put it up here. I have minus 1x. And plus 3x minus 1x gives me plus 2x, so I'm right. Okay? So then I'll let each bracket equal 0. So I get x plus 3 equals 0. And I get x minus 1 equals 0. So x is on one side, numbers on the other. So x is equal to minus 3, and here x is equal to 1. Is that okay? Right. I have two x's. What have I to get? 2 matching y's, don't I? So you go right back up to the top. So you go y equals x cubed plus 3x squared minus 9x. Okay, so I have to get a matching y for each x. Can I move this up like this? Right, so everywhere I see an x, first off I'm going to put in a minus 3. So that means y would be equal to minus 3 to be cubed plus 3 times minus 3 to be squared minus 9 times minus 3, and I think that's 27. Okay, am I right?
Yeah.
That's my, yeah, okay. So that point is minus 3, 27. And then I have to get a matching y for this x. So into this, everywhere I see an x, put in a 1. So it's y equals 1 to be cubed minus 3 times 1 to be squared minus 9 times 1. So that would be wrong, because I have a wrong sign written down. This is a plus, isn't it? Okay, so that's 3 take away 9, which is minus 6, and I should be, oh yeah, and that 1 there, that's minus 5. So that point is 1 minus 5, which is what one of the answers they told me I'd get, so I know I'm right. Okay? It says find d2y dx2 is part 2. So I know dy dx was equal to, I have to go back up, what do I get for dy dx? 3x squared plus 6x minus 9. 3x squared plus 6x minus 9. And then they said get d2y dx2. Okay, differentiate there. Bring power down in front, you get 6x plus 6. Is that right? Okay. And then it says use the second derivative test to determine each of the turning points. So I have 2 turning points, right? Okay. Now I know, right? Minus 3, 27 is, that's across to minus 3, way up to 27. 1 minus 5 is across to 1, down to minus 5. So I know which one, I know the answer before I start, don't I? Right, okay. So what I have to do is I have to check out each point. So minus 3, 27, and d2y dx2 is 6x plus 6. So into that, instead of x, I put in minus 3. So I'll get 6 times minus 3 plus 6. Into the calculator with that, I'll get minus 12. Minus 12 is a negative number. So the fact that it's a negative number means this is a max turning point. Okay? The other point then was 1 minus 5. So into d2y dx2, instead of x, I'm going to put in a 1, because x is 1 here. So that's 6 times 1 plus 1, plus 6 even, right? 6 times 6. 6 times 1 plus 6 is 12. That's a positive number. And if you end up with a positive number, that means it's a min turning point. Okay, and that's it. Is that alright? Okay, so there's a reason for using differentiation, right? So at the start of the chapter, we learned how to do differentiation, and I said, I'll hold off on the reasons to do differentiation. So one was to find the slope of the tangent to the curve. The second one was to find the turning points, right? So now today I'm going to do the third reason to find dy dx, right? And the third reason to find dy dx has got to do with rates of change, okay? So if you just write this down and then we do an example and it'll make more sense. So when you see those 3 words, right, when we saw the words find the slope of the tangent to the curve, we differentiate. If they say find the turning points, we differentiate. Okay, and I'll give you a list of all the times you differentiate at the end of when we've it all done. Okay, but so far, if it says find the slope of the tangent, we differentiate. If it says find the turning points, we differentiate. Here's the third time we differentiate. If they tell us a story and they say find the rate of change of whatever, okay, we differentiate. So those 3 words, rate of change, tell us that we need to differentiate.
What's the word after difference?
Differentiate. So it's like different, IATE. Is that the word you asked me?
Yeah.
Yeah. if a body, right, and by body I mean what they're talking about. They might be talking about a ball, they might be talking about a rocket, they might be talking about a car, they might be talking about a person running. So a body will stands for whatever they're talking about. So if whatever they're talking about is stopped, the speed is 0. That'll all make more sense now in a minute. Okay? So I'm talking specifically here about rates of change. The rate of change of distance means how fast you're going. How quickly are you changing your distance? That means how fast you're going. That's speed. And the rate of change of speed is acceleration. Okay? So rates of change, I'm talking about distance, speed, acceleration. So I'm talking about 3 specific areas. Okay? So distance, if you differentiate distance, you get speed. If you differentiate speed, you get acceleration. You need to learn this. Okay? Because differentiate means finding the rate of change, and the rate of change of distance is speed. And differentiate again means you're finding the rate of change of speed, which is acceleration, right? So these are the 3 words we use in life: distance, speed, acceleration. So to go from distance to speed, you differentiate. From go to speed to acceleration, you differentiate. If you have to go from distance to acceleration, you differentiate twice. Okay? Okay, we'll see an example now in a sec. Yes? If a body is stopped. So what I mean by a body is, we'll see in our examples, I think I'm talking about a rocket, and maybe the next one is a football. It just says a body in the other one. So a body could be a football, it could be a person running, it could be a car, it could be a train, it could be a rocket, right? It's whatever's moving in the question. Okay, so that's what I mean by body. Right, okay, I'm not on the cube with your one, the body, right, okay, it's a body is just car, train, person, whatever I'm talking about. Okay, so what I'm going to do is I'm going straight to an example, right, and I'll explain this further as I go through the example. Okay, so I'm going to give you a chance to write down the example first because it's long. S, that says S meters. Okay, so they're calling distance S, right? If anyone here does physics, does anyone do physics? No? Yeah, in physics they always call distance S, don't they? Yeah, so that's where the S comes from, right? Okay, and to be honest, it's a bit confusing because to me S should stand for speed, but it doesn't, it stands for distance. Okay? So a body moves along a straight line and its distance, S meters, from a fixed point after t seconds is given by, here's the equation. Then find its speed after t seconds, find its speed after 2 seconds. After how many seconds is the body at rest? Find its acceleration after 3 seconds.
seconds sounds like 1 second.
No, just t seconds. It'll just have a t in it. We'll see it in a minute. Don't panic about what any of this means just for a minute. We'll just write it down and then you can listen to me. Write it down.
Yeah.
Everyone? Right, okay. So before I even read what they want me to find out, right, okay, the first thing is, you see this equation S. Now S is distance, right? Don't get confused, right? It's a physics thing. S is distance, okay? So they told me distance S. Right, sorry, you're on freeze. Right, okay. So here, S is distance. So I'm going to use the word distance, right? Because S is confusing to me. So distance is equal to 3t squared minus 4t plus 6. Right, before I've even read the questions, I know if I differentiate distance, what you get? Speed, don't you? Differentiate distance, look. Differentiate distance, you get speed, agreed?
Yeah.
Right, so I'm going to call the next line speed and I'm going to differentiate. So what would speed be equal to? 6t minus 4, wouldn't it? Agreed?
So you're leaving the 6 because there's nothing.
I brought the 2 down in front. 2 by 3 is 6. Reduce the power in the t by 1.
Yeah.
So I just have a t instead of an x.
Okay.
Right? Okay? Is that okay? If I differentiate again, look, if I differentiate speed, what'll I get? Acceleration. So I'm going to differentiate again and get acceleration. Yes? Yeah. So differentiate speed, I get acceleration. Differentiate again there, what'll I get? 6. Right. So see the way I have 3 statements now. They only gave me 1, but now I have 3 equations, don't I? Distance, speed, acceleration. Yes? Right, now I'm going to read the questions. Okay? So when you see questions like this, I want 3 equations written up at the top. Okay? So before you attempt to answer the questions, I want 3 equations written up at the top. So you write down distance, which they will give you. They'll always give you distance. Right? Then I want you to differentiate it and call it speed. And then I want you to differentiate it again and call it acceleration. How do you know this? You learn it. Okay? Right? So part 1. Find its speed after t seconds. So they're looking for speed after t seconds. You've done already, haven't you? What's its speed after t seconds? 6t minus 4. After t seconds means there's a t in there. Leave the t in there. Are we okay with that? So I have it done. Right? Part 2 asks me to find its speed after 2 seconds. So speed after 2 seconds. So again, we're looking for speed. So I have my 3 equations. It says find its speed, so I'm looking for speed, and I know speed is equal to 6t minus 4, but this time I want to find it after 2 seconds. Anyone make a suggestion? Put 2 in for t, exactly. T stands for time, right, in seconds. So everywhere I see a t, put in a 2. So it's 6 times 2 minus 4, which is 8, isn't it? 6 2s are 12, take away 4 is 8. Got it? I did. 6 2s are 12, 12 take away 4. I'm going straight to the answer because I'm assuming you're typing it into your calculator and pressing equals. Okay? Which is always the safest thing to do. Right? Okay. Part 3. Now, they love this question. After how many seconds is the body at rest? So, let's think about it. The body at rest is another way is the body what? Stopped. Right? And when something is stopped, tell me about, what do I know? Speed is 0. When something is stopped, that's why I put it here, because they love this question. When something is stopped, its speed is 0. Okay? So, I know, they said it stopped. So, I know that the speed equals 0. That's what stopped means. When something is stopped, it's not moving, so its speed is 0. Okay? But I have an equation for speed. What is the equation for speed? 16 minus 4. So that's equal to 0. How am I going to solve that? Yeah, t's on one side, numbers on the other. So leave the 6t, bring over the minus 4, becomes a plus 4. And then divide each side by 6. And that means t is equal to 4 over 6. If you put that down into your calculator, that'll be 2/3. Okay? You don't have to. If you left it as 4 over 6, you get full math. S seconds, it's time seconds. Is that right? Okay. They love that question. Right? So, no, well, you'll see, we'll get through the complicated ones, but, right, as long as you have your 3 equations at the top, right, and in your question you say, are they asking me about distance, are they asking me about speed, are they asking me about acceleration? So then you pick out the right equation, and then you either let it equal to 0 if it's stopped, or you fill in a number. Okay?
Yes.
Right, part 4.
What's the number underneath the 16 and the 4? So the 6?
Yeah, 6, yeah, 6 and a 6. There's 6 stuck to the t, so I divided each side by 6. Right, can I move it up?
Yeah.
Right, part 4 then. Part 4, back to the question, sorry, I've it rubbed out. What did part 4 say? Find its acceleration. Right, do I have to do any calculations here? They're looking for acceleration. It's acceleration. Do you know? It's acceleration. Right, I may have written this question down wrong because, hang on, it doesn't matter. I'm just going to leave it. Can I just rub out the after 3 seconds? Just find its acceleration. Because I did write it down wrong. Yeah, doesn't matter. Right, what's the acceleration? 6. Done. Okay, I wrote it down wrong, so there would have been a t to fill in there. Okay, but it doesn't matter. Its acceleration is 6. Right, so we won't change it. Okay, got it? Right. Oh.
Was the question wrong?
No, it's fine. It's fine. It's just, yeah, it would never ask you for its acceleration after 3 seconds if there was no t to fill in. So there was no t to fill in because I wrote it down wrong. But it's fine. You don't need to find its acceleration. Was all. Just cross out after 3 seconds, and the question is fine. Okay. Example 2. I'll give you a chance to write it down because it's good and long. 100t minus 5t squared. Yeah.
So I would have x in the question. Is that the distance or the speed? Or not the distance or the second?
Say that again?
So how you said x meant distance?
Yeah.
Is that
The
correct?
S here, they actually wrote out the word, but I got lazy. So the S there stands for after 2 seconds, after 3 seconds.
Okay, thank you.
Okay. You might write out the words actually, because I never thought of that. Okay. So, you know, part 1, the height of the rocket after 2 seconds. It actually wrote seconds in the question. I was just being lazy. Right. Are we ready? Are we okay? Can we read it?
No.
Okay, in this question, guys, they're talking about a rocket going up, right? It's still distance. Height just means it's distance straight up. Is that okay? So for height, read distance, okay? Because height is the same as distance. So what happens to a rocket? A rocket is like the same with a ball. When you throw it up and up and up and up, right? Okay. Eventually, does it get faster or slower as it's going up? It gets slower as it's going up, doesn't it? Eventually what happens imagine it was a ball. A rocket's probably a bad example because you think there's an engine on it, but they don't, just means they threw something up in the air, right? So if you throw a ball up in the air, it gets slower and slower and slower and slower. Eventually what happens to the ball in the air? It stops, doesn't it? And then it falls back down, isn't that right? And as it's coming back down, it gets faster and faster and faster and faster, right? So when you throw a ball up, right, okay, it gets slower and slower and slower and slower. Eventually it'll stop. And it'll momentarily stop and then it'll fall back down again, won't it? And as it's falling, it gets faster and faster and faster. Okay, I will do this tomorrow. Will you have a go, please, at page 261 and 2, right? Just do your best with them, right? I have a lot more to do before I can leave you off, okay? But just have a go with them, right? We'll finish the example tomorrow and then we'll correct the homework.